Hey everybody, welcome to this lesson on ionic bonding. The topics that will be covered in this video will be a quick recap of what ions are, as well as some basics on how ionic bonds form. For the really important stuff, you feel free to skip through, but we'll be looking at how to write ionic formulas using monoatomic atoms, as well as some polyatomics for the year 10s. Year 9s, you don't have to worry about that this year. So what actually are ions? If you remember correctly from your periodic table, all the elements there are what we call neutral atoms, which means that there are equal number of positive and negative charges. So if you look at sodium as it exists in its elemental form, you'll see that it has 11 protons, 11 neutrons, and 11 electrons. So the positively charged protons and the negatively charged electrons are all equal in number. When we form ions, electrons are gained or lost by an atom, and so therefore there becomes an uneven number of positive and negative charge. So when sodium forms an ion, it actually loses an electron. So therefore it has 11 protons and now 10 electrons. Because these numbers are uneven, there's an extra positive charge which gives an overall positive charge to the sodium ion. So why would elements form ions? Essentially, they want to form an ion to get a full outer shell. If you remember correctly, the group on the very right-hand side of the periodic table are called the noble gases. They are very unreactive, and if every element would like to have a configuration just like them. So to do that, they will lose or gain electrons to form ions. Metals will lose electrons in order to form positive ions, which is called a cation, whereas nonmetals will gain electrons to form negative ions, which are called anions. So when ionic bonding actually occurs, it is a bond between a metal and a non-metal atom. The metal will donate some of its electrons, 1, 2, or sometimes 3, to the non-metal. Now both of these atoms will form ions with either a positive charge in the case of the metal or a negative charge in the case of the non-metal. Now, just like the two halves of a magnet, these ions, when they've got positive and negative charges, are very strongly attracted to each other. And it is this attractive force that actually forms an ionic bond. This is actually very strong. It can be broken, especially with ions that dissolve in water, but it is still a very, very strong bond that won't break without any help. Now, when it comes to writing ionic formulas, the key thing to remember is to balance the number of positive charges and the number of negative charges. Now, in terms of tests and exams, you won't need to memorize or to work out the kinds of ions that each element forms. You'll be given a table of ions, just like here on the right, so you will be expected to use it. Year 10s, if you're looking at this in semester 2, you are given all of your 5 polyatomic ions in the table because your formula writing is not a big part of this exam. However, you'll still be expected to know how to form a complete ionic formula. So we're going to start from the basics with our monoatomic ions. So let's take a simple example such as sodium fluoride. If you look back at the previous ion table, you'll find out that sodium is a 1+ ion and fluorine forms a 1- ion. When they come together to form a bond, we have an equal number already of positive and negative charge, one positive from the sodium and one positive from a fluorine. So that being the case, it's a really simple matter of forming the formula. Again, our basic rule of metal before non-metal, so don't write in alphabetical order, metal first, then your non-metal. Because there's one atom of each, so for every one atom of sodium, they'll bond one atom of fluorine, you don't have to write any numbers in the formula, you just leave it as it is. Now, in scenarios where you may have uneven number of charges, that's where we're going to have to add numbers and muck around with how many atoms we have per molecule. So in the case of magnesium chloride, we have a magnesium which has a 2+ ion and a chlorine which have a 1- ion. If we count up the number of charges, you'll find that we actually have an extra positive charge and not enough negatives. So to balance this out, we can actually add one more chlorine ion. With the chlorine ion comes an extra negative charge. So overall now, we're not going to have one negative charge, we're going to have 2. Now in this case, we now have a completely balanced molecule. So to write this as a formula, we'll have MgCl2. Now this 2 here indicates that there are 2 chlorines, not 2 of the entire molecule, but 2 of the atom directly preceding it. Now, the other thing we can do to make life easier for ourselves is what's called the crossover. This is particularly handy when it comes to atoms that have different charges or different numbers of charges each side. And this is foolproof. It will work every time, even when you think you don't need it. So what you do is you take the charge on the positive ion, and that will become the number of anions you actually need. So in this case, we have 2 plus on the magnesium, therefore we'll need 2 chlorines. On the opposite way, there's only 1 charge on the chlorine. If we cross over, that means we have 1 magnesium. Now again, we don't have to write that 1 magnesium in, but by doing this crossover trick, you can then have a quick and easy way to get to your correct formula, which still gets us to MgCl2. Now polyatomic ions, you can look away at this point, you're all done, or if you want to keep watching for your own amusement, you can, but for Year 10s, this is for you. In the event that you have a polyatomic ion, you'll be given the charge for the complete ion and will be expected to treat it as if it's a monoatomic ion with the same charge. So in this case, we're going to do magnesium hydroxide. So magnesium, as we know, has a 2 plus, and hydroxide altogether has a 1 minus charge. Again, similar to the previous scenario, we have an extra positive charge, so we're going to have to add in an extra negative to balance everything out. Now, when you're adding a negative charge, you have to add the whole hydroxide ion, not just an oxygen or a hydrogen. Now, when we are writing this whole formula, because we have a polyatomic and we need to put in 2 of them, you need to add a 2 in brackets to indicate that there are 2 OHs. If you write OH2 without the brackets, that indicates that there are 2 hydrogens, 1 oxygen, which is in fact OHH, or our old friend, water. Not the correct thing. It is very different from 2 hydroxide ions, so please be sure to use your brackets when you need to. Now, if you would like to use the crossover rule when it comes to polyatomics, it acts exactly the same. We have a 2 plus charge on the magnesium, which therefore means we are going to have 2 hydroxides, and again, pop our brackets in. We have a 1 minus charge on the hydroxide, which means we're going to have 1 magnesium. Still gives us the same answer, makes life a lot easier for a lot of people, especially if you like to use the same process for all types of problems. So that's all, everybody. Thanks heaps for watching. Questions and comments in the section below, or feel free to email me. Definitely tell me if this video was worth watching, and see you next time.